Hello again. This is Ms. Nakayama, and today's lesson is 5.5b, Trigonometric Equations Part 2. So we're continuing our study of solving trig equations, and this video is going to highlight or concentrate on those equations that you have to use an identity to solve them, and then those equations that the solutions can't be found on the unit circle, so you have to use your calculator. So want to make sure you know how to do that properly. So let's jump right in. Our first example, using an identity to solve a trigonometric equation. We've got cosine of 2x plus the sine of x equals 0, where x is between 0 and 2 pi. So we know we're not going to have the plus 2 pi in at the end of this. So what you want to notice is that a couple of things. One is I have two different trig functions. I have a cosine and a sine. And secondly, I don't have the same variable. Like this is, or the same angle. This is x and this is 2x. They have to all be in the same type angle. So that's enough to tell me I need to make a substitution for the cosine of 2x. That's a double angle that we just covered last week. And we have three different formulas. So which one do I want to use? Well, I'm going to use the one, if I get rid of cosine of 2x, okay, I can either put cosine squared minus sine squared, cosine squared minus 2 cosine squared minus 1, or 1 minus 2 sine squared. Well, the other trig function in my problem is the sine of x, so that means I'm going to use the one that has just the sine function in, so that all of my problem will be in the same trig function. So that means I'm going to have, instead of cosine of 2x, I'm going to write 1 minus 2 sine squared x, and then I'm going to bring down the rest of the problem. So what we had here, this is my substitution using an identity. Then I'm going to treat it like we talked about in part A. So I'm going to rewrite it all in the same, I'm going to leave with my squared, okay? So I have 2 sine squared minus sine x minus 1 equals 0. So what I did, okay, from here to here, 2 sine squared x, notice that what I did was I changed the sign of everything. My 1 is now negative, my sine squared is positive. Don't know why that happened. And my sine is now negative. That's because I don't want to factor something that has a leading coefficient that's negative. So I just divided by -1 and then rearranged the terms. So again, factoring 2 sine squared means 2 sine x and sine x. Factoring 1 is just 1 and 1. And then you got to figure out which one's positive, which one's negative. Then we're going to set each factor equal to 0. I'm going to solve for x. So that means I'm going to subtract 1 first. Then I'm going to divide by 2. And over here, I'm going to add 1. So I now need to find x is going to be the angles whose sine is -1/2 or 1. And you're going to get your unit circle out. The first one is going to be 7 pi over 6. The next one is 11 pi over 6. And then the last one up top at pi over 2. And that's what we have for our answers. If you're interested, I'll show you how you can get those answers on a graph using class calc. All right. Using an identity to solve a trigonometric equation. So we have another one here. 2 sine squared minus 3 cosine x equals 3. Okay. Again, I do not have the same trig function. Okay, one is sine and one is cosine. I do have the same angle. They're both x, so that's good. So I'm not using a double angle or half angle or anything like that. But you need to keep in mind the fact that there's a squared here means that this, I can look at my Pythagorean identities and I can make a substitution of my 2 sine squared. My sine squared is equal to 1 minus cosine squared. So I have made that substitution of just sine squared x equals 1 minus cosine squared x. Then I'm going to distribute my 2 in the parentheses, bring the rest of it down. Now, this time, because I have things on both sides of the equation, then I'm going to take everything to the right side. So that means I'm going to have 0 equals 2 cosine squared x plus 3 cosine x plus 1. I'm going to factor 2 cosine x, 1 and 1. Everything's positive. Set each factor equal to 0. Subtract 1, divide by 2, subtract 1. So my angle, x equals, where's the cosine negative 1/2? Cosine negative 1/2 on the green line in second and third quadrant. So that's 2 pi over 3 and 4 pi over 3, and cosine is negative 1 over at pi. So those are my answers. All right, going to the calculator. Okay, one last thing I'll say about this, y'all. Every problem is not going to look like this, but you're going to have to use some kind of identity if you don't have the same trig function. I don't know why this keeps happening. If you don't have the same trig function or the same angle, you got to remember to use an identity. All right, solving trig equations using a calculator. Solve the equation correct to 4 decimal places for x between 0 and 2 pi. We have the tangent of x equals 3.1044. So I think everybody knows by now. So if I'm looking for x, I'm looking for the angle, then I'm going to use the inverse tangent button. So if you want to think x equals, this is how you put it, inverse tangent of 3.1044. Okay, this right here tells you your calculator must be in radians. Okay, not degrees. So pay attention to that. So when you do that on your calculator, the first thing that you should get is x equals 1.2592. Okay? Remember, we've talked about there's more than one place on the circle where tangent is positive. So in our first, if you think about our unit circle, okay, up top or over to the left, I have pi, which in radians or as a decimal is approximately 3.14. And up top is half of that, which is 1.57. So my angle of 1.2592, you can see, is in the first quadrant. There's my angle. So the tangent is always positive. Wherever it's positive or wherever it's negative, they're always directly across from each other. That has to go with that period of pi. So I know the other angle is going to be down here. So all I have to do is add pi to it, or 3.14159. Add pi on your calculator, and you will get the other answer, which is 4.4008, because they wanted it in 4 decimal places. So whenever you're dealing with tangent, the easiest way to do it is to just remember to add pi to get 2 answers. If your calculator gives you a negative angle, a negative answer to begin with, add pi and then add pi again, and you will get your 2 answers between 0 and 2 pi. All right, last example, solving a trigonometric equation with a calculator. So this time we're doing the cosine of x equals negative 2/5. So inverse cosine of 2/5 means x is going to be equal to 1.9823. Okay, so where is that? Well, remember we got 3.14, we got 1.57. Okay, so my first angle, cosine is negative in the second and the third quadrant. So the first one is from here, from the origin, from our positive x-axis to there. That's my 1.9823. But now I have to figure out how to name this guy to here. Okay, so 3.14 minus 1.9823 is that angle right there. And this angle is the same. So all I have to do is add these two together, and I will get my other angle of 4.3009. Okay, there are other ways to do it. If you find a shortcut of doing it and it always works, that is absolutely fine. But just tell me how you do it. Thank you so much for watching. Remember your identities. You can hopefully see how important they are when you're trying to solve equations. Thank you again for watching. Y'all have a great day.